Today's lesson is about distillation column unit operation. Distillation is a process of separating the components or substance from a liquid mixture by selective boiling and condensation. As a result, a complete separation near a pure component, or it may be a partial separation that increases the concentration of selected components of the mixture, and all the components are present in liquid and vapor phases. These are the types of distillation column, which are batch, continuous, fractional, vacuum, and zone. These are the difference between batch, continuous, fractional, vacuum, and zone distillation column. The efficiency are demonstrated graphically by plotting changes in temperature of distillation over time. A good separation will result in high efficiency, while low efficiency indicates poor separation. Next, distillation column application widely used in industrial scale, such as raw oil will be separated using fractional distillation column. Separation between alcohol and water are one of the examples in lab-scale application. Moreover, food processing also use this unit operation to refine palm oil before sending it to the customer. The steps are same goes with the herbal distillate. To be noted that this distillation is not used as a true purification method, but more to transfer all volatiles from the sources materials to the distillate. In distillation column, there are three zones, which are enriching zone, feed zone, and stripping zone. Each of the zones has their own mass balance. For feed zone, to find Q, we need to use either these two equations, or some cases, the equation of Q will be told. If the Q is more than 1, the liquid is below boiling point, while if the Q is equals to 1, the liquid at boiling point, and if the Q is between 0 to 1, it is a mixture which contains liquid and vapor, and if the Q is equals to 0, it is saturated vapor, and if Q is below than 0, it is superheated vapor. Total reflux tells us about limitation of the tower. When R over R plus 1, or we call it slope, in enriching zone, it's at 45-degree lines, which indicates minimum number of threads. For feed zones, to find Q, we need to use either these two equations, or some cases, the location of Q will be told. If the liquid is below boiling point, the Q will be more than 1. If the liquid is at the boiling point, the Q will be equals to 1. And if it is a mixture which contains liquid and vapor, the Q is between 0 to 1. And if it is a saturated vapor, the Q will equals to 0, and if it is a superheated vapor, the Q will be less than 0. Total reflux tells us about limitation of tower. when R over R plus 1, or we call it slope, in enriching zones is at 45-degree lines, which indicates minimum number of straight. To find minimum reflux ratio, or Rm, we will use this equation, which y prime and x prime we will get from the For fit zones, to find Q, we need to use either these two equations, or some cases, the location of Q will be told. If the liquid is below boiling point, the Q will be more than 1. If the liquid is at the boiling point, the Q will be equals to 1. And if it's For fit zones, to find Q, we need to use either these two equations, or some cases, the location of Q will be told. If the liquid is below boiling point, the Q will be more than 1. If the liquid is at the boiling point, the Q is equals to 1. If it is a mixture which contains liquid and vapor, the Q is between 0 to 1. And if it is a saturated vapor, the Q is equals to 0. And if it is a superheated vapor, the Q will be less than 0. Total reflux ratio for fit zones, to find Q, we need to use either these two equations, or some cases, the location of Q will be told. If the liquid is below boiling point, the Q will be more than 1. If the liquid is at the boiling point, the Q will be equals to 1. If it is a mixture which contains liquid and vapor, the Q will be between 0 to 1. If the liquid For fit zones, to find Q, we need to use either these two equations, or some cases, the location of Q will be told. If the liquid is below boiling point, the Q will be more than 1. If the liquid is at boiling point, the Q will be equals to 1. If it is a mixture which contains saturated For fit zones, to find Q, we need to use either these two equations, or some cases, the location of Q will be told. If the liquid is below boiling point, the Q will be more than 1. If the liquid is at boiling point, the Q will be equals to 1. If it is a mixture which contains liquid and vapor, the Q is between 0 to 1. If it is a saturated vapor, the Q is equals to 0. And if it is a superheated vapor, the Q will be less than 0. Total reflux tells us about limitation of the tower. When R over R plus 1, or we call it slope, in enriching zone is at 45-degree lines, which indicates minimum number of straight. To find minimum reflux ratio, or Rm, we will be use this equation, which y prime and x prime, we will get it from the graph. And after we find the Rm, we will be used to find the optimum reflux ratio.
Hello everyone, my name is Akil bin Adlan and I would like to further explain about the McCabe-Thiele method. So what is this method? This method is used to analyze the binary distillation. Binary distillation means that a distillation of a mixture with two components. Simply said, it is mainly used to determine the theoretical number of stages or trays required in the distillation column. This method was created by McCabe and Thiel, hence the name McCabe-Thiel method. So let's take a look at McCabe. Warren Lee McCabe was an American physical chemist and is also known as one of the founding fathers of chemical engineering. Together with his partner Ernest Thiel, a chemical engineering researcher at Standard Oil and a professor of University of Notre Dame, they created this method. Now this method involves a mixture of two components. So for this video's sake, we go for simplicity. We are going to use the mixture benzene and toluene. Now for the whole process of this method, we are only going to use the composition data of the lighter component of the mixture, which is benzene. So for the first step of the McCabe-Thiel method is to draw equal size vertical and horizontal axis. As you can see here, the y-axis is the vapor composition of benzene and the x-axis is the liquid composition of benzene. The second step is to draw two lines. First is the x equals to y line. The blue line, as you can see here, also known as the 45-degree line, and the vapor-liquid equilibrium curve. Don't worry, the vapor-liquid equilibrium data is always given, so you don't have to worry about that. Now step number 3 is to draw the enriching, stripping, and feed lines. The way you draw this is by using the equation my friend Hanis has explained before, by using the y equals to mx plus c method. So after acquiring the data, you can plot the graph. So before we start plotting, we have to assume that the liquid composition at the distillate is 0.95 and at the feed is 0.45 and bottom 0.15. So there are two ways to approach this. One is to draw the line, the enriching line, or start from the stripping line. So for this video, we'll just start from the enriching line because it's the most usual way we go. So to do this line, basically you just from the intersection point of the 0.95 distillate the liquid composition with the blue line, and then just use the data you obtained and make a straight line using the plots you've done. Now the next step is to use the feed line, the Q line. So for the sake of simplicity, we just assume the liquid at feed is at its boiling point. Therefore, Q is equals to 1. So just create a straight line, a straight vertical line. So as you can see there's an intersection between the Q line and the enriching line. From this intersection point, just create a line from that point towards the bottom point, which is like this. And there you have it. Alright. So now that you've done this, it's time to determine the number of stages that is required in this distillation column. This is a simple step. From the top point, just create another line from the intersection point of distillate and the blue line towards the equilibrium curve, and then pull it down, and then as you can see, that's how you do it. After doing this, all that's left is to count the number of stages. I'll make it easier. Alright, because that one of the stages at the bottom part is not full, so we will not include it in the count of stages. As you can see here, there are 7 stages. So these 7 stages are including the reboiler, and as you can see, the feed line is under the 5th tray. And there you have it. That's the McCabe tail method, or at least the simple explanation about it. Thank you very much for listening to my video, and I hope you have a good day.